Today, inshallah, we're going to continue the remaining part of hospital information systems. And the first thing we're going to talk about is about common guidelines for interfacing PACS, HIS, and RIS. Basically, we said that basically RIS is a subpart of HIS, as we said before, okay? But actually, it's a specialized part of HIS. And both of them have to interface to PACS, and because PACS actually is a very specialized software, it's a little bit different from HIS. It has some, you have to actually worry about whether these two systems will be compatible or not. So basically, in this part, actually, we're going to talk about some basically best practices of how to do that, okay? So let me give you an example first. If I tell you that basically your computer should basically interface to another computer, basically you wanna basically network two computers, okay? And in order for this networking to happen, I will have to take the motherboard of your computer and change the motherboard of the other computer and put another, basically a newer motherboard or a different motherboard that has special interface, hardware and software in order for this interface to happen or for this network to happen, basically. Would that be acceptable to you? If you rely on your computer, you usually like the configuration of your computer the way it is. When I tell you that I'm going to change the motherboard of your computer in order for this computer to be interfaced to another computer, then you have to worry, okay? Because you have no guarantee that your computer will perform exactly the same after this interface. So basically, this is definitely something that you have to worry about in this interfacing thing. We have interfacing between PACS and HRS and RIS. So basically, the most important thing, or one very important best practice that you have to do, is that each system will continue to function exactly the same, with the same capabilities. It's exactly the same, unchanged in its configuration. So basically, just consider that it's before the interface and after the interface, it's exactly the same. It performs the same, okay? It doesn't have any changes in the configuration, in the hardware, in the data, or the functions, okay? So this is very important because basically, you don't want to change, or basically the interface shouldn't change the way each one of them works individually, okay? So this is very important. Let's go back to this example of interfacing two computers through a network. The most common thing that people do right now is just to add a network card, okay? If you have a network card, then basically you add that network card on top of whatever you already have, and basically it allows you to interface to other networks or basically other computers in the network. So basically, this is the second recommendation here. Each system is extended in both hardware and software for allowing communication with the other systems. So this is the simplest way. Basically, you can extend your system. You don't change or reconfigure your system. Extend means that you're adding hardware or you're adding capabilities without changing the existing hardware or the existing software. You're extending them. You're adding other functions, but the original functions are maintained exactly the same way. So basically, you extend each system. If you want to interface PACS and HRS, for example, you add something to PACS, extend the software and hardware of PACS, and do exactly the same for HIS in order for these two systems to be interfaced. The next guideline is that only data are shared while functions remain local, okay? This is definitely very important. Basically, you're sharing data only. You're not sharing functions. Because basically you need to have all the functions localized. Basically the functions that PACS, functions of PACS system or the function of HRS and the function of IS are very specialized functions. And it's better to keep the functions localized in each one of these systems while sharing the data. For example, if you want something from PACS, if you, for example, want to store a report that was actually written based on basically the reading on a PACS workstation, basically, for example, you don't do that yourself. You don't go from PACS and store it directly to EHR. What you should do is probably interface with HIS, send the data, send the request to store that report in the EHR of the patient, and the HIS does that. So you're sharing data, not functions. Okay, this is very important. If you do that, things will be much more organized, basically. And basically, when you do that, you're keeping each system specific and autonomous. Okay, and this will simplify the interface process. Just imagine that the HIS is interfaced with the database that has the EHR. Okay, and you have the PACS somewhere else. Basically, if you want to interface with HIS and with EHR directly, then this would be a much more complicated way of doing things. Because basically, your interface, the HIS interface with the EHR is basically, this is one of the main functions of HIS. So basically, this interface is well established, and basically, you're making sure that everything is unique and everything is you're not overlapping things, or basically you're not doing things. You basically accounting for all the activities that happen on EHR. When you have another system trying to write to EHR, then how would the HIS know about that? Then this would be a problem actually. And basically it would complicate the interface in order for you to keep track of what goes on in the EHR, because basically so many different systems are trying to modify the EHR, and basically all need to know about what goes on so that they don't repeat the things, or basically don't cancel whatever. If I write here, I don't want the HIS to update in a different way, for example. Okay, so basically keeping each one of them specific and autonomous will simplify the interface process. Okay, and this is very important. You share only the data, so the interface would include data exchange. Data includes basically, for example, reports, would include the patient information based on requests. You request the data and you receive the data. You don't really get the data yourself from the database. So this is really important. The last thing, and this is probably going to be the part that we're going to talk about after we finish HIS, is about the standards. Okay, so basically, first of all, you have to configure all the messages or all the data exchange between the different systems based on standards. We talked before in EHR about interoperability, where we have basically different systems dealing with basically, if you imagine that you have a hospital information system, for example, you don't have to have the PACS from the same company. You don't have to have the RIS from the same company. Basically, you have to have these systems able to communicate with each other. So in order for you to be able to do that, you have to actually use such standards as HL7, for example, health layer 7, okay, or health level 7, basically. This is one of the standards that would ensure that the messaging protocol or the requests or the data format would be compatible between the different systems. So this is extremely important. And also it's very important before we do that to identify what kinds of data that will be basically allowed to be exchanged. So for example, we talked before about access rights and authorization and things of that sort. It doesn't make sense, for example, for an RIS to request basically some reports from the patient, for example, from patient record. Okay, RIS shouldn't be able to do that. PACS should be able to do that, because basically you're talking about a doctor sitting and trying to diagnose an image, and he needs to, or he suspects something, and he needs to see the medical history of the patient in order for him to confirm his diagnosis. Okay, so he should be able to access such information. But for RIS, for scheduling a certain diagnostic procedure, something like that, or a certain imaging procedure, you really don't need to access the patient data. Basically, you just need to schedule the study, and that's it. Okay, so basically you have to actually think very hard about what should be done and what should be exchanged between the different systems. This is very important, and this is a key part of the system. After that, you make sure that all the messaging happens according to standard formats, according to certain the standards that you talked about in the EHR, including HL7, for example, or DICOM or whatever, so that you can basically allow for exactly whenever you send a message, it will be understood. You can interoperate different systems from different vendors. You don't have any compatibility problems, and your commands are understood properly, and you receive exactly the kind of information that you expect from the other system. Okay? So basically, when you do HL7 standard format, you basically, you're thinking about high-level presentation. High-level presentation means that how the information will be presented to the user. Solving data inconsistencies, for example, if you have basically, if you receive different pieces of information and you found that there is an inconsistency between them. For example, if you get some piece of information from RIS and from HIS or from EHR, you need to be able to resolve any problems that might occur there. You should actually have a reference, or basically have priorities for, or basically I can say that credibility for different sources, so that you know, for example, whatever you get from the EHR has more reliability than whatever you get from RIS, for example. Because sometimes when you enter the request on RIS, it might actually be entered improperly or incorrectly. For example, if the patient information is incorrect on RIS, then it might be from manual error in data entry, for example. Whatever is on EHR should be exactly the correct or the absolute truth about the patient, for example. And usually have certain naming conventions about things. For example, if you're talking about labs or lab results, or you're talking about ECG results, you should have certain naming conventions so that you know exactly how to call things. And we're going to see that on the HL7, inshallah, maybe today or next time, inshallah. I think it's probably next time, but we're going to see how these naming conventions actually work. Usually use common data models and data language, and define rules for correspondence between the various data definitions. Basically, you're talking about data models, like, for example, we're going to talk about something called what you call it, relational data model, for example, where you have a data like a table, for example. You have rows and columns, okay? And basically, there is other models like object-oriented data model, for example. You actually have to define the data model that you're using. And basically, you have to use a kind of a data language so that you can update, or you can properly read the data in the correct format. For example, we're going to talk about things like SQL, one of the database, one of the most commonly used databases. And basically, this can actually serve as the data language, where you can actually read the data, you can update the data, you can append, you can do whatever you want. And the rules of correspondence means that how you're going to, who is going to initiate which correspondence. Usually, you have various correspondences that we're going to see in some examples in a second. And basically, you have to basically decide which one of these systems should initiate that correspondence, and which ones should basically be responsible for answering, and things of that sort. So basically, you define the whole thing, the whole interface through the HL7 standard. Okay. After that, you have to have a certain protocol of data transfer. For example, if you're using a network, for example, you can use TCP/IP, for example. One of the things that we saw in the networking part of this course. Okay, so basically, can be just plain, basically Ethernet networking, for example. You can use other things like the DICOM. The DICOM standard, actually going to talk about, inshallah, today. We're going to start talking about it today. Basically, this is one of the things that you can actually consider. So basically, you have to decide how the data will be transferred between the two systems, the protocol itself. Okay, so here you're talking about the message itself, and here you're talking about the technical aspects of how the message will be transferred between the two systems. You have to decide about these things. Please, if you have any questions, you can interrupt anytime. Okay. So these are the kinds of examples that we should talk about. Basically, if you imagine that you have HIS interface with RIS, and basically interfacing that to PACS. Usually you have that interface, going from HIS to RIS and between RIS and PACS, because it doesn't make sense for PACS to go directly to HIS. Okay, as we said before, RIS is a part of HIS. we said that HIS is a collection of information systems. One of them is radiological information systems. Okay, so basically you have different things that you can actually consider here. For example, when you have patient admission, basically this will actually insert the patient demographics here in RIS. If you have a patient admission and this patient will have to go through a radiological procedure, then you get the patient information from the admission here and insert it in the RIS. Okay, and if you're going to open a file for the patient on PACS, then you actually get the same information from whatever you got here on RIS, you get it here exactly the same way in the PACS. Okay, so basically this flows like there, from here to here. Maybe I can take an opposite example here. Here you insert the report text. After you do everything, you insert the report text here. The doctor on the reading workstation writes the report. And basically you go through RIS where it's approved there, and then basically you make that report accessible to basically the patient, the doctor, everything through the HIS on the HIS part here. So basically the flow goes from here to here. So basically here the PACS initiated the correspondence and basically it reached RIS, and once it's here, it's basically going all the way up to RIS. You can actually think about other things like, for example, when the patient arrives, you can actually have an event when the patient arrives, it should actually communicate with PACS so that you can actually start and basically have a certain image folder, okay, after the patient finishes. So basically, you know exactly, you create the folders where the patient information or the patient study will be stored, for example, okay? Things of that sort. So basically, we don't have to go through all of them, but actually you have to just think about the kind of communication that happens, okay? Another one at the end, basically, maybe you can just go through the order entry, for example. Order entry means that the doctor prescribes a certain radiological procedure for the patient, okay? So basically you receive that order here on RIS and you do the scheduling here based on the order entry. And then this goes to the PACS where you actually prefetch basically a lookup table, and basically you retrieve the information of the patient and put it in PACS so that whenever the study is done, you have all the information of the patient so that the doctor can use it in the diagnostic procedure. At the end, basically, whenever the patient is discharged, for example, you get the discharge from HIS, and basically what you do here is just you clean up the patient information. You don't need to have it locally on the RIS. Basically, you keep the data on RIS and on PACS as long as the patient is in-house, basically in hospital, basically. If you have an inpatient hospital, then you keep all the information, because basically it's an ongoing process. Basically, it's basically the patient is still there, and basically you need all the information, all the procedures that were done, because the doctors are looking at everything as long as the patient is there. Once the patient goes out, once the patient is discharged, then you can just basically keep the data in the EHR, and whatever you need it later on, if he's admitted later on, then you can retrieve it again. But for now, you clean up the patient information from the RIS and you clean the images from PACS. I'm talking about here the short-term storage, of course. It's already in the long term, as we said before in the PACS part of this course. Okay, so you don't need to store the data in the short-term memory or short-term storage here. Okay, you can actually store it in the long-term storage so that if you need it later on, basically you can retrieve it, but you don't really need it to be in the short-term memory, because you cannot keep everything in the short-term memory. So you have to clean up patients as long as they are discharged so that you have enough memory for the new patients. There are so different events, so many different events, like admission, like order entry, like arrival, like examination complete, like dictation. Basically, we're talking about, for example, things like how to write the report. Sometimes you actually have a way of doing the dictation as basically a speech text. Okay, so basically the doctor, instead of writing the report, he basically dictates the report, and the computer system actually translates that to a text report. The doctor reviews that, makes sure that everything is okay, and basically approves it. This is one of the things that you might have. You might have a transcript. Basically, it's like a preliminary report. You might have a signature. Basically, you allow the doctor to confirm. Whenever the doctor confirms, you can actually do some kind of digital signature. And things that transfer, if the patient is transferred to another hospital, you might actually trigger something like this. Basically, patient transfer, if he transfers to another department or transfer to another hospital, you might actually do whatever is needed, to free up the space here. But actually, sometimes you don't have to clean up the images. You can just migrate it somewhere else, or basically it depends on the kind of transfer that happens. But actually, most of the time it's very much like the discharge. Okay. So basically, you have different events, and depending on these different events, you have basic communication with these three systems. Usually, the communication between HIS and RIS happens directly, and between RIS and PACS, it's very rare to have PACS directly connecting to HIS. So whatever PACS needs, basically, it can basically fetch through RIS. So basically, it requests from RIS, and if it doesn't have the information, it requests that from HIS and goes back all the way to PACS. As an implementation, of course, it's kind of difficult to actually talk about implementation, because actually it's kind of very technical. It requires a lot of programming knowledge so that you can actually know how to do that, especially database programming. But actually, we're going to talk about general strategies, not very specific ways of doing that. Okay, we're not gonna do that ourselves. It's kind of an involved process. Okay, so basically, you can do the interface based on trigger mechanism. Okay, meaning that the systems are working basically based on, or basically the communication happens based on trigger mechanisms. Meaning that whenever certain triggers, like the ones that we saw in the previous slide, whenever one of them happens, it would trigger the communication to start. And this communication would start in a certain way. Okay, for example, if you have a patient admitted, then it would go from HIS to RIS to PACS, for example. If you have a report, then it would go the other way around. Okay, if it has a report, it goes this way. Okay, so basic admission goes this way, and basically report goes the other way. So basically, you define exactly how these things happen, basically. So for example, PACS is notified of events like ADT, like the kind of events that we saw in the previous slide, basically in HL7 format whenever they occur in RIS. Okay, so basically you don't have to remember these, you don't have to think about them, but there is a set of very well defined events. Whenever they happen, basically PACS has to be notified, because basically it has to prepare or it has to accommodate whatever these events do. Okay, so basically the application level interface software waits for the occurrence of one of these events and triggers the corresponding data to be sent. For example, if you have an admitted patient, or basically this is admission, discharge, and transfer, basically. So basically, if it's admission, it triggers certain types of data to be sent. If it's discharge, it's basically going to signal that this patient is discharged, so that you can clean up the data. If it's transfer, it depends on the kind of transfer information. You send the transfer information so that you know exactly what you should do. Okay, so basically it depends on the kind of message or the kind of trigger. It would actually trigger the corresponding data to be sent, and basically based on these data, you can decide what exactly you're going to do with them. Okay, or what each system should do based on the data. Okay, and basically the communication level transfer HL7 files basically to the PACS server. So basically you're talking about using HL7 standard, and basically this is very much the standard communication protocol between any medical informatics systems in general. Okay, so basically whenever you receive such data, the PACS server would receive the file, the HL7 file, and archives it for its database table for subsequent use. And basically it's used in a systematic and timely fashion when small amounts of predefined information from RIS is needed from PACS. So basically, this is ideal when the data size you have is basically is very small, and you have very limited set of predefined triggers or predefined information that you already know or already prepare for, so that you can deal with very effectively. Okay. The disadvantage is that you require some additional storage allocation in both databases, which is basically allocated for whatever messaging, whatever data you receive from the other system, you have to store somewhere. You cannot receive data from RIS and store it in the PACS archive, for example. You can't do that, okay? So basically, you have to have another database. You can say, for example, PACS database application programs. Basically, you have a certain storage or a certain database that is basically dedicated to storing the data that you receive from the RIS, for example, okay? And basically, you use such information. Maybe some part of them can actually go to the PACS archive at the end, but actually not all of them. In the meantime, while you process the data, you have to keep it somewhere. And basically, you have to have a database that allows you to do that. Okay? So basically, if you have communications going the other way around, you have to also have another database here to allow you to basically store the information that you got from PACS, so that you can process them first and then decide what you will do with them next. For example, if you receive the report, you have to, first of all, the message that contains the report, you have to store it somewhere in the RIS before you process it and send it to the HIS. Okay? So basically, in this case here, you have certain triggers, and depending on these certain triggers, you know exactly whenever a certain trigger happens, you know exactly what to do. Okay? If you go back to the previous slide, you actually have certain actions here. You have certain event here, and there is certain action here, and you know exactly what you're going to do with this, basically, and you know exactly where, basically, where the message, who starts the message and who receives the message, or who receives that event, and you know exactly what to do after you receive this message. So basically, it's like an event-driven system where you're just waiting for certain events to happen. Whenever these certain events happen, it would trigger the communication between the different systems, and data will be transferred based on exactly what each message does. Okay, so you predefine what each event should have, or the kind of data you need for each event, and whenever that event happens, you transfer that set of information or that set of data to the other system. The other way of doing that is that basically you're using a query protocol, okay? This is basically like you're dealing with databases, basically. Query is very common in database systems. I'm not sure if you're familiar with such systems or not, but query is whatever we do when we deal with database. So you allow access to information from HIS, RIS, and PACS databases by using an application layer software on top of these heterogeneous databases. So for example, you have RIS, and RIS has a certain database, and you have PACS, and PACS has a certain database. Instead of basically driving everything as an event-driven system, basically you have a certain way of query that database through a certain interface on PACS. So basically you add a certain software that would allow you to basically query the other databases in the other systems. Okay, so basically, given that these databases might not be exactly the same, okay, might be actually using different models, for example, this interface software should allow you to basically ask for the information, and this information will be translated to the, for example, here, the proper format for the RIS database, and basically this does the query and basically get the data and prepares the data in the HL7 package, and basically sends it back to the PACS system. So basically, you request a certain query, and this certain query would be sent usually through TCP/IP or whatever, just the internet. Basically, it's just a network. You have a network here somewhere, somehow. Okay. Usually, you're talking about a network like a local area network here, because usually you have these systems inside the hospital. Okay, you're not talking about something. Sometimes you can actually interface everything through internet, so everything is basically, but it's not very common actually to have such systems exposed to the internet. Usually you have them on a local area network, and you have a firewall between you and the internet so that you have more security. So basically, usually you assume that you have TCP/IP between the different systems. So basically, you send that query, and that query would be translated to the proper format for the RIS database, and basically you execute the query, get the results, and basically format them properly and send them back to PACS. Okay? So here, for that example, from the PACS workstation, user can retrieve information uniformly from any of these systems automatically, and automatically integrate them into the PACS database. For example, if you need the patient data, for example, patient information, if you need one of the basically previous results from one of the patient lab reports, for example, okay, you can actually retrieve that so that you can include it in whatever you have in the PACS database. If you're going to have a certain report, you can actually include that information in that report. Okay. And usually for all these interfaces, basically you have to have application layer software that uses specific standards. For example, if you're talking about global query language for databases, usually SQL is very commonly used. Usually for the database model, you use relational data model, meaning that basically you have your data as a table, basically, meaning that you have certain, basically you have patients, for example, here, and you have attributes, for example, here, like certain piece of information. You have for each one of these patients, you have such information. For each one of these attributes, you have information for each patient so that you can query that. Okay. Usually you use TCP/IP because basically you have a local area network. You're not supposed to expose this to the internet so that you be more secure. And whenever you're sending anything between the different systems, you use HL7 data format so that the compatibility between the systems is maintained. Okay, so basically, I just want you to basically realize the difference between the two systems, or basically different approaches that people use for the implementation of the interface, where you can actually do that based on certain events, or you can actually have a little bit more control and do it as a query protocol where you have more freedom, actually. In the query protocol, you can do things that might not be predefined, okay? So it gives the user a little bit more freedom or more flexibility, but actually basically if you want to have access authorization and things of that sort, it might be actually better to use the event-based system so that you can actually define exactly what kind of information and which information goes from which system to which system. So you have everything predefined so that you have more control over the access authorization, and basically you maintain some of the, if you want to implement such access authorization in a query-based system, it might be a little bit more tricky to implement. So basically, all what we talked about is a part of chapter 13. So if you want to read a little bit more, you can actually go through that chapter in that textbook. That it's basically one of the textbooks that we have on the system. Okay, you can access it and basically look at this chapter. What we talked about in the HIS, I just wanted you to realize, or basically start to think about the issues that people face when they are trying to basically build a hospital information system that would be compatible with the other systems. It's very important to realize that hospital information systems and radiological information system, any information system basically has to have a lot of information about what goes on in the hospital. You have to design everything around the workflow of different activities in the hospital. You have to ensure that you're compatible with the other systems, because you have no guarantee that the other systems will be exactly the same as yours or from the same company as yours. So basically, it's very important to make sure that you use standards like HL7 and DICOM and things of that sort, so that when you communicate information, you're basically communicating things that can be understood by the other systems, regardless of whose vendor, who the vendor was. Any questions before we move on to the next topic? Okay. So I'll just close that now. Can you see the other presentation? Okay.
Yes.
Okay. Thank you. So now we're going to talk about medical informatics standards. What we're going to do is we're going to talk about only 2 standards because basically you have a lot of standards, and it would take a whole course, more than a whole course actually, to study medical informatics standards. And we're going to just touch about very few things about each standard, but we need to actually get the idea about what these standards do. Okay. So let's be more specific. We'll start with DICOM. Okay, the DICOM format is a very well-known format, and it's a very well-known standard that people used in exchanging images in particular. So basically, it's not made for signals or for lab results or things of that sort. Basically, it's basically, from its definition, it's an acronym for Digital Imaging and Communications in Medicine. It's DICOM, D-I-C-O-M. Basically, this is the abbreviation for this Digital Imaging Communications in Medicine. It's an internationally accepted standard for storing, exchanging, and transmitting medical image data. So basically, you have 3 functions here. How to store, how to exchange, and how to transmit. Okay, this is very important. And when we talk about DICOM, before we actually get into the detail, basically maybe can talk up, and then we're going to realize how versatile such a standard is. So the features of this standard would include how you store the images, how you retrieve the images, how to display the images. Okay, which is very important. Okay, display actually used to be on printers. Okay, like on films or things of that sort, or on basically whatever media. Sometimes you actually get the images on like a video printer would actually print the image on thermal paper, for example. Okay, now it's mostly on monitors. Sometimes you think about this and think that why would display be a problem? Okay, because basically if you have a certain image, you get the image data, then you can display it definitely. Okay, we're going to see that there are very strange things that happen in different modalities, and one of these things is how to display the image. For example, some imaging modalities would have, if you have an image that has data for each one of the pixels from 0 to 255, you usually assume that this is black and this is white, and in the middle you have gray levels. Okay, right? Do you have any objections to that? Do you have any different way of doing that? It doesn't seem like it seems logical to be like this, right? Actually, it might be the way to do things for you, but actually in other systems, it might be exactly the opposite. So in other systems, as we're going to see, sometimes you have the 0 as white and the maximum here as black, which is very strange actually. Okay, and this is very important because whenever you're transferring the image, you have to actually have that convention with that. Okay, you have to know exactly how to display these numbers. It's not just the numbers. Okay, it's not basically the numbers by themselves are not enough to tell you how to display the images. So for certain imaging modalities, you might have different conventions for these numbers. So you need to know how to map these numbers into the grayscale. Okay, so this is very important. Okay. So by agreeing and unifying on common standard, mixed vendor environment is possible, like interoperability. Basically, this is what we're aiming for. It doesn't make sense, if you started your medical informatics systems in your hospital like 20 years ago, it doesn't make sense to basically keep working with the same company, that basically might actually be closed now. If you have a system from a company 20 years ago, it might not be, in business right now, or it might be basically a different company now, or working with different technology that might be very different from what it used to do before. So it doesn't make sense to rely on vendors to basically create things that are compatible. Basically, you have to actually force such things with common standards, with a standard that apply to everyone, regardless of what they do. Okay, so if you agree and unify such common standards, basically you allow for that mixed vendor environment. So basically, whenever you're if you have a certain PAC system, for example, and you want to get a reading workstation, for example, you can get it from anyone. You don't have to get it from the same vendor, or you don't have to get an RIS from the same vendor. You can get an RIS from a very different vendor. Okay, so this is very important. In order for us to realize the problem that was before actually DICOM was introduced, in the early 1980s, you had ultrasound images, you had CT, you had MRI by that time, they were all available. And unfortunately, each vendor had a proprietary encoding for the images, meaning that each one of the vendors would have a different format for its images, okay? And it's very difficult. It became apparent that it was very difficult for medical imaging to be viewed or stored outside of the boundaries of the original acquisition modalities. Meaning that if you have a CT that was that old, that was like early 1980s, if you want to see that image, if you want to, for example, examine a certain study from patient, you have to actually sit on the CT system, on the console of the CT system, in order for you to be able to see that image. You cannot use these images. You cannot use the image data, even if you got the images out of the system and put it on another computer. You have no way of opening that image. You have the image format is basically unknown to you. Proprietary means it's like a private format that you don't know about. Okay, proprietary means that I do things my way, and I don't tell you exactly how I do it. I consider it as a know-how. So basically, I don't want anybody else to know how to do it, so that I'm the only person who can actually decode it, okay, in order for people to see it, okay. So this was very bad actually, and basically this was very difficult, and basically hospitals were forced to, purchasing all the equipment from a single manufacturer. Basically, if you want to have a PAC system, the only PAC system that would work with your CT, for example, is the same PAC that comes from the same company. Other than that, it's not going to work. So basically, it's very difficult. And basically, recognizing the need for greater coordination between different vendors and systems in the new area of medical informatics, groups began to debate possible solutions. People started thinking what to do about this. And in 1985, the initial DICOM specification was first published jointly by National Electrical Manufacturing Association, is NEMA. This is one of the things that I think you already saw some of the standards of NEMA about, when you talked about, when you did your report about digital displays. And there is also another one that also was relevant to the image displays, was ACR, is the American College of Radiology. And basically, the first version was ACR NEMA DICOM format that was introduced in 1985. And basically, the main aim of this standard was to allow interoperability. This is the key word here. Allows different images to be read by different vendors. Okay. The current version of DICOM right now is DICOM version 3. Okay. And basically, it has now another standard, which is the ISO 12052, which basically it's if you have the DICOM version, it should be enough. But actually, this is another standard that might actually it's like one of the common, because ISO is a more common standard for use basically. But actually, it's if you have the DICOM version 3, it's already included, and basically. It's implemented in the ISO 12052. Okay. The very nice thing about DICOM format is that it's free and easily accessible. This is really nice. Okay. You can access it on the internet via NEMA website, so you can download the whole standard, okay, for free. And whenever there is an update, you can actually download the update, without any problems. This is a very different way of doing things than the HL7. HL7, we're going to see that it's not for free. It's actually done by a private group, and basically you have to pay in order for you to be able to access the HL7 standard. Okay, so basically this is very different. This is like a community, effort that was made public and free for everybody to use, and this is really nice. This is basically, I prefer that sort of collaboration between different people in order for common standards that would be good for everybody to be accessible to everybody. Okay. One very nice thing also is that the current version of DICOM, which is DICOM version 3, is in use since 1993. So DICOM version 3 was introduced in 1993, okay? And it remains until now as a DICOM version 3. This doesn't mean that it's basically a stagnant, or basically it didn't change since then. No, there are many changes that happened since then, okay? They have regular updates, but actually they're retaining the same version number. So basically you have 3 point whatever, okay? And basically this means that it's a subversion of 3, but it's still, the really nice thing about this is that all current updates are forwards and backwards compatible. This is actually one of the features that are that would make actually this standard as a very nice standard. You don't want to have a standard basically that would, whenever you come up with an update, it would make the newer version of the standard incompatible with the older versions. Because basically there are so many different systems that are working with DICOM since in the 90s, basically. And if you introduce something in the DICOM format or the DICOM standard that is incompatible with the other systems, this would mean that the newer systems, the newer basic system that would use the newer standard would be incompatible with the older images. And this is not acceptable, basically. So basically, as long as you have version 3, you should be able to read whatever images that were created with version 3, regardless of the format, okay? So basically, it has wide-ranging compatibility between the old and the new equipment, even when recent technologies had not been foreseen originally, such as Bluetooth connected DDR imaging plates. It means that basically, if you might not know exactly what these are. These are the kind of image receptors, the digital image receptors that were used, for example, for dentistry, for example. Okay. Now, instead of having a sensor that is connected by a cable to your imaging equipment, you can now have a sensor that is connected via Bluetooth to your imaging equipment. Okay, so you transfer the images or transfer the data from the sensor to the equipment using Bluetooth. Okay, and basically it doesn't have to worry you basically, because basically it's an added standard here. If you have Bluetooth, then the Bluetooth part of the standard would apply to that. But at the end, the data that you will have in your DICOM format will be actually compatible with any system that was introduced before the Bluetooth was introduced. Okay, so this is very important. Okay, so the current version remains as the same as version 3 since 1993, but there are updates that would take care of the newer technologies that are introduced every day, basically. And the nice thing is that it's forwards and backwards compatible. Okay, so basically you have wide-ranging capabilities among devices that work with DICOM version 3. Okay. As a result of these nice features about DICOM, it's estimated that basically you have interoperability, because basically this would allow interoperability between very different systems. And basically this made an estimate of a trillion, if you imagine, trillion is a very big number, trillion medical images can be viewed and transferred with DICOM today. Okay, so basically there are at least trillion images, and they are increasing, that you can use DICOM format to open. So you don't have to have anything but a DICOM reader in order for you to be able to see any one of these trillion images. Okay, this is very different from other formats. some people, maybe in the early 80s, as we talked before, the different vendors try to push certain formats that are basically their formats, okay? But these formats actually peaked and waned, meaning that it actually, they received some interest, and after a while, people actually thought that it's not gonna be as good, okay? So basically, they started actually waning away from such formats. Basically, they don't really exist anymore right now, okay? So basically, the only format that people agree about for medical images is the DICOM format, okay? So if you have older equipment, like for example, if you have a nuclear medicine scanner, like a legacy nuclear medicine scanner, it can happily coexist on a network with a cutting edge volume reconstruction or image analysis systems that are basically DICOM compatible. So basically, you don't have any problems with older systems using the DICOM format, which is really nice. So the DICOM as a standard contains a number of parts. Basically, right now they are 18. They used to be 20, but actually 2 were retired. Basically, they are not updated anymore, or basically people found that they are not useful. So basically, you don't really update them anymore. And basically, the document defines a standard way for data to be formatted, how you actually put the data into the file, communicated, how you transfer the data between different systems, and presented, meaning that how to display the medical images on medical imaging systems. These are very important things, okay? And basically, you do that during the creation, the management, and the exchange of these images. So basically, whenever a system like a medical imaging system creates these images, if you're going to, for example, acquire certain MRI study, for example, you take care of the creation of the image using the DICOM standard. If you're talking about, the reading of the image, for example, you actually do that in DICOM standard. Like display is part of the management of the images. You do that with DICOM standard. If you're going to manipulate the images, you do that also through the DICOM standard. And the nice thing about that is that whenever you manipulate the images, you keep the original data, and you keep basically a log of whatever changes you made. So that when you want to display the changed image or the manipulated image, you can do that. But if you want to go back all the way to the original data, you can do that. And of course, how to exchange the data between different systems, this is also very important. So by creating common standards, this allows imaging acquired on one manufacturer's device to be viewed on another compatible device much more widely, and is the basis of how we are able to mix and match different pieces of equipment within our departments, okay? For example, if you want to have a PAC system that comes from, for example, Siemens, okay? And you have an imaging system that comes from GE, for example, okay? They will happily coexist. They have no problems, okay? As long as you're using, basically all of them are using DICOM formats, it's not a problem for them to communicate, okay? So this is extremely important, okay? So as a whole, the DICOM standard defines a set of protocols or rules for manufacturers to use, how to create the images, how to put the images, and what kind of information you include with the images. And this is very important. You have certain syntax, which is the arrangement of how to do that, semantics, meaning of each one of these pieces of information, of commands, and data models and relation means that the relationships between the different things that you actually put in the DICOM format. Okay, so basically you have a certain way of arranging your data inside the DICOM file. You have certain information that you have certain meaning. Okay, it's not, by the way, it's not just the image that you put there. You put also the information of how you basically about the manufacturer itself, the piece of equipment that you use to acquire the data, the settings of that piece of equipment, basically if you have some kind of a certain, for example, grayscale, or how to display the image, you put that as well. You put information about all about the patient himself. Some information about the patient has to be included with the DICOM image. So basically, this is how to basically the kind of data, how to put them together inside the DICOM file, And the meaning of each one, for example, if I tell you that the patient ID, you have to actually have a certain meaning of that patient ID. Would it mean that it's the national ID or the patient ID on the hospital information system, or what basically you have to actually explain each one of the items that you send through the DICOM format. And if you have a certain database, you have certain relationships between the different data parts, you actually have to define them. Okay. You have guidance on standardized formatting of data. So in each one of the fields that you have in the DICOM file, you basically have a certain way of putting data, like certain format that is preferred. And also you have to define also communication methods that you can use in order for you to be able to exchange the image with another system. So basically the DICOM standard would actually have to cover all of them, actually covers all of them. So you have certain pieces of information that you, or basic certain terminology that people use in the DICOM format, like for example, the modality. It means that the discrete type of imaging specialty like CT, MRI, ultrasound, whatever. There's something called application entity title, which is basically the names of the services or applications communicating within a network, typically used to identify individual pieces of image acquisition equipment. Like for example, you might have multiple CTs or multiple MRIs and whatever. You have to actually have a certain way of identifying each one of them. So basically, you have the application entity title, means that it's basically a certain unique identifier for each one of the systems that you have on your network, for example. Okay. You have what's called modality work lists, which is a service that provides a feed of demographic and exam data to image acquisition equipment. So basically, if you have a certain work list that, or basic certain list of patients that have to be examined by a certain piece of equipment, you have to actually have that list as a modality work list, so that basically people know exactly what to do. And usually this is very useful because instead of asking the patient to take a paper from the doctor to the imaging equipment or the imaging technologist, he can actually see whatever the doctor wants, and basically doesn't have to ask the patient, or basically if there is something missing basically between the doctor and the patient, or basically if it's just oral communication between the doctor and the patient, he tells him that you go and do this kind of scan, and basically doesn't give much information than this. Basically, here you can actually transfer everything or have everything very specific and provided to the technology so that he can know exactly what to do. There's a way of doing query or retrieve operation, basically, which allows you to retrieve certain piece of information from the DICOM data, for example. Basically, you're doing a search or a query for a particular attribute. For example, you're looking for a patient name or patient ID, a date of birth, and things of that sort. And basically, you're talking about such things where you're looking for a certain study, for example. You have your data stored as DICOM images, and you want to get the DICOM images that correspond to a certain study for a certain patient. You can actually do queries in order for you to be able to do that, and you can use any of these attributes to be able to find that study. You have also what's called association. All these are very common DICOM terminologies. So basically, if you mention association in terms of DICOM or in the context of DICOM, it means a connection or a conversation between two programs. So basically, if you're communicating the image between your modality and the PAC system, for example, this is an association. Okay. Whatever you're going to talk about is called the service object pair. Okay, class. Okay, SOP class. It's equivalent to the topic of the conversation, that if you're going to talk about, for example, a certain patient study, for example, if you're talking about, for example, a sub-image of a certain study, for example. So basically, you're talking about the topic of the conversation, and it's framed in the context of the actor, which means that the thing doing the action and the action required. So basically, if you're talking about doing a query, then basically the thing that is going to do the action is the entity that has the images, for example. And the action itself is a query, is basically to search for a certain attribute, for example. So basically, we have also service class user and service class provider. These are the two ends of the service class action, basically. Whatever we talked about before, basically, talked here about service object pair. Basically, if you have a connection between two systems, one of them will be a user, one of them will be a provider. Like basically, you can basically relate it to a client server. Okay, one of them would act as a client. He's asking the server for a certain service, and the other one would basically provide it to that system. Okay, so basically, the service class user (SCU) and the service class provider (SCP) are the two ends of a single connection at any one time. So basically, if you have any connection, it has to have one SCU and one SCP. You cannot have two communications or one communication that doesn't have these, basically. One has to be asking for something and one has to be providing that something for it. Okay? So basically, SCU is the end initiating the contact. Basically, this is the one that requests the service. And SCP is basically the receiver or the responder of that request. Okay? Sometimes you have something called composite and normalized operations. Okay? Composite operations are basically, it's like if you have certain operations that would have multiple steps, then basically it's composite operations is a part of one part of this composite operation. So basically it's one of the steps in the composite or the complex operation that would happen. Okay, so basically such operation would usually start with C dash whatever. Okay, you have certain, like for example C store, for example. Okay, for example, then this is actually a part of a certain composite operation, but this is only one part of it. Sometimes you have normalized operations which start with N, okay, and such operations actually are self-contained, basically. Like basically it's just one command, basically, or just one operation that would happen. Basically, just one command would just do it. Okay, this is kind of rare, but actually it was actually taken into account in the standard. So if you wanna basically understand these terminologies of terms of a regular, human interface or human conversation, basically, application entity would mean that it's a person. Association would mean that it corresponds to the conversation itself. SOP class, it's the topic of the conversation. SOP instance is a piece of information inside that conversation. Transfer syntax is the language. Service is a form of conversation, which means that it might have different things, basically. It might be basically a lecture, question and answer. It depends on the kind of conversation that goes on. If you're talking about offline media, it's like a printed book. Okay, if you have application entity, let me go back, and application entity title, basically it's like the person's name. Okay, so for example, if I talk about here, I talk about modality, for example, you have a CT, but this CT has to have a unique name, and this name actually is like the person's name. So basically, when that person or that identity or that piece of equipment tries to communicate with other pieces of equipment, it would use its unique name so that it can be distinguished from the other ones. So basically, let's see some examples about some basic DICOM file movement operations, for example. One of the operations is like CStore, basically. If you have such operation like CStore, as you see here, it's a composite operation, so it's a part of another composite operation. This is one step of that operation. So basically, it sends data for storage. It's very simple. If you have cfind, you're searching for something. If you have cmove, you're it's very common actually to use very clear names actually for these commands. So move, you basically moving something from one place to another. Get, you're getting a copy from something, basically from the database to your system. If you have C echo actually is very much like ping that we saw in the networking part. So basically just making sure that you're checking that the connectivity is there. Okay, you're just making sure that you can communicate with that system. So basically, if you send a C echo, you would receive like whatever you got, and on ping, for example, you get a message that assures you that you are in good contact with that other system. Okay, so basically for the C store, for example, there are some safety checks that you should actually take care of. Okay, so basically you have such a service called storage commitment. Okay, storage commitment is very much used to make sure if you want to store a certain image, you want to make sure that there is enough storage space in your computer before you do that. Okay, basically, if you start that command, if you start the C store without enough data or enough space in your hard drive, for example, or the local storage, then the operation will later fail. So basically, it will take some time, and basically at the end you will fail. So it's better to check the space before you do that in order for the operation to be successful. Okay, so this is very important. Okay, so basically it avoids the equivalent of common issue found on standard operating system with the file copies for several minutes before an out-of-memory message is displayed. You have to remember that images are really huge in size. So basically, it's not uncommon to try to store things like multiple gigabytes, many gigabytes of data they're trying to store somewhere. So basically, multiple gigabytes of data, they will take minutes, actually, literally, it will take more than minutes to actually store them on a local drive. So basically, if you start that operation and at the end you fail, then you wasted time and basically the operation failed at the end. So you want to avoid such things. You check on that and basically start the operation only when you make sure that you have enough space. Okay. So the cfind, you search for something and return the results. The cmove, you basically copy an object in a certain place, basically. Usually you can move a DICOM image, but sometimes you move other object, but it's a kind of rare, basically. Because sometimes you have other information other than the DICOM images, but actually it's kind of rare to use something other than DICOM right now. If you want to get a copy of a composite object, it's basically exactly the opposite. Basically, if you find something on the database, you want to get a copy of it, you use get. Okay. Basically, you're talking about if you have cget, if you started a certain association means the link or a conversation. Basically, if you use cget, you can get a copy of a composite object without starting a new association to do so. So you don't have to start, if you already have an association with another system, you can actually get the data without having to start a newer one, okay? For the echo, just making sure the association is working or the connection is working between the two systems. So basically, a simplified basic process of establishing connections in DICOM would consist of you basically have a certain user, basically, as we said before, SCU, it's entity wanting something done. Okay, it communicates or starts the communication, initiates the communication, as we said before, with the SCP. It's the provider. Okay, and basically, it's basically the SCP is the entity that can likely do this operation, basically. And you first start by negotiating the technical protocol, meaning that if you have a certain network connection between you and that other system, you negotiate exactly how you're going to transfer. Like, for example, what kind of language this would be sent, and basically the kind of connection itself, the speed of the connection, things of that sort, so that the two are compatible. And basically, you try to, of course, have as fast as possible connection. So basically, you try to make sure that the top speed, you reach the top speed of your network, communication. and basically use an understandable language in order for you to be able to receive the information without any problems. Okay. We're talking about here, sometimes the language we talk about here is a kind of encryption, for example. Sometimes you send everything over the network encrypted in some way, okay? So basically you have to actually have an understanding between the two so that whenever you send a certain encrypted file, for example, you should be able to decrypt it on the other side, okay? Once you do that, once you finish that negotiations, you have an association, okay? You started an association now. Okay, association, as we said before, is like a conversation. Okay, so basically it's like basically you have two company bosses, for example, want to negotiate certain deal, for example. Okay, they start with lower level employees arranging for their meeting. Whenever the meeting is arranged, the two bosses will start talking together directly. Okay, so basically this is very much like this. Okay. Once this association is established, through this association, requests that we saw before, like store, like get, like query, things of that sort, will be passed between the requester or the entity, the user, and the provider, so that you can actually do the composite operation that you need. Okay. Sometimes you need composite or normalized. As long as you have an association, you can actually use whatever you need. Okay. Once you have an association. After whatever you need is done, basically the association is then closed, and basically if you need to communicate again, then you start from the beginning, okay? So this will happen whenever a communication or whenever a certain exchange of information is needed between two DICOM systems. So basically, it's one of the very important things that you have to study very carefully is something called DICOM conformance statements. Okay, basically it's a very important but extremely lengthy document that is issued for each piece of equipment, such as PACS or CR console or CT scanner, and details in depth particular machine-specific compliance and implementation of the DICOM standard. What it means is that, let me try to give you an example. It's like the you have certain way of doing things. Okay, you have certain specifications for each one of the functions of the DICOM. Basically, everything that we talked about, how to start a communication, like an association, for example, how to do composite operations, things of that sort. You have very specific definition of how they are going to be done. But actually, each implementation might be a little bit different. So basically here, each one of the vendors would detail exactly how he does every part of the DICOM standard. So basically, this is why it's extremely important and extremely lengthy at the same time. You might think that all the implementations should be exactly the same, but actually people found otherwise, okay? I know people who were working on DICOM systems that suffered actually to get some communication. Sometimes the implementation would differ very slightly, but this very slight difference between different systems might actually cause problems if you want to have proper interoperability. So basically, for example, if you have for example, for legacy systems, for example, you have certain, compliance with DICOM standard, and basically some of the newer updates of the DICOM standard might not be implemented. Like, for example, what I just told you about Bluetooth connection with certain image receptors, for example, okay? So basically, this will be actually seen in the DICOM conformance statement of that equipment. So this is extremely important, okay? And basically, you refer to this conformance statement in order for you to be able to ensure that the implementation is exactly what you basically think it is, okay? So although the overall DICOM version has remained unchanged for years at version 3, additional functionality and methods have been added, as I told you before. So if you read the conformance statement of any new incoming piece of imaging equipment, basically this becomes critically important to determine any compatibility or workflow issues that might arise. So for example, if you get a newer piece of equipment, are you assuming that it conforms to the latest version of the version 3, or latest update of the version 3, okay? Latest upgrade or a latest addition of version 3. For example, you assume that it has a Bluetooth connectivity. And basically in the conformance statement, you find that it's not compatible with that version of DICOM, okay? So you know that it would not basically, it would interface with any sensor but the Bluetooth one, okay? So basically you know that you might have to change some of the things that you have, and this might change the workflow in your system or your radiological department, for example, okay? So this is extremely important, okay? And it's extremely important to realize that this review should be carried out well in advance of purchasing decision being made by those in charge of managing the packs in conjunction with the department lead wishing to purchase or add new equipment. So basically, if you are the biomedical engineer, then you'll probably be the technical person who will be basically in charge of basically managing the packs installation. And basically, the radiological department, for example, might actually be planning to add new equipment, and such new equipment might be talking about things like wireless communication between different sensors that are used to acquire the image, for example, okay? And this is not basically, it was not added to the version 3 of DICOM until 2020, for example, okay? So basically, you need to make sure that the conformance statement of the pack system that you're going to purchase is actually, basically, it includes all the additions that were added in the 2020 version. Okay, so basically, you need to just think, not just think about whatever you have right now. You need to think about the future as well. So if you're going to, or you're planning to have a system that would, take advantage of the newer additions in the PAC standard or the DICOM standard, you have to actually make sure that whatever you need is in the DICOM conformance statement. Otherwise, you'll basically realize a year later that the DICOM format or the DICOM standard that is, in use for, by the PAC system you have might not allow you to basically upgrade your systems in a certain way. So this is extremely important. And basically for the DICOM conformance, by the way, we're talking about every piece of equipment that deals with DICOM. So basically, we're talking about image acquisition modalities, like each system, each imaging system you have, like if you have a certain CT scanner or ultrasound system or MRI or whatever, if you're talking about PACS, if you're talking about reading workstation, if you're talking about any, basically any imaging equipment, any image viewing equipment, any PAC system, must have DICOM conformance statement. And it's very important to start, if you're going to basically decide on a PACS system, you have to start with that. You have to start with the DICOM conformance statement in order for you to be able to compare the different systems, and you have to be, you have to get the people in the radiology department involved so that they tell you exactly what they plan to do in the department, so that you do the things that are basically you make the right choice for the long term, not just for the whatever you have right now. Basically, there's something called Modality Perform Procedure Step, MPPS. It's a very useful DICOM service, but actually not widely adopted within the radiology community at the present. It allows something that would have a kind of feedback to be sent from image acquisition station, such that individual parts of the diagnostic examination can be sent separately. Let me give you an example here. It's actually maybe it's here. Historically, if you have a very urgent case and the doctor needs to see the images for a certain radiological study very quickly, he cannot wait, basically, he might actually ask for wet films. Wet films means that, if you remember before, we used to use films, we have to actually process these films. And whenever you process these films, you have to actually pass them through chemicals, and you have to remove such chemicals, and then you have to dry the film in order for the doctor to be able to use it. Sometimes, if the doctor is in a hurry, He can ask for wet film. He cannot wait for the film to dry. Basically, he needs the images so urgently that he can accept the wet films. Okay, so here we're talking about the digital age version of this. Okay, you're talking about basically allowing the doctor, for example, if the patient goes to do MRI, he doesn't just do one image of MRI, for example. He does several studies, for example. He can do T1 weighted, T2 weighted, proton density weighted. He can sometimes do diffusion imaging. He can do several studies within the same examination, okay? And basically, what this procedure would allow, or what this service would allow, is that whenever one of these studies is done, he makes that part of the examination available to the doctor earlier than the whole scan, the whole study, okay? So the diagnostic examination would include several parts. Whenever a part of this examination is done, it would make it available to the doctor as early as possible, okay? So basically, we're talking about progress update, meaning that whenever, for example, if you have a multi-body part examination, you can actually, whenever you image one part, you send it to the doctor right away. Okay, so basically, he can actually view it, before the whole study is completed. Okay, this is kind of one of the optimizations. I'm not sure if you have, it's not that common for this to happen right now, but actually, you have to think about, it might actually, for urgent cases, for example, if the doctor needs to decide quickly about the management of the case, for example, then this might be a little bit interesting. So basically, this is one of the things that might not be widely adapted, but actually it might, in the future, it might be a very, very important service to consider when you actually decide about, a DICOM conformance statement. There's one of the terminologies that people use actually is a composite instances, which means that it's part of more than one. Okay, means that if you're communicating data between different systems, sometimes you cannot communicate the whole thing at one time. Okay, as I said before, if I have a study, usually a study might have different examination, or basically might have different like T1 weighted, like T2 weighted, like photon density weighted. So basically, you might send this as a separate DICOM file from this. Okay, you have different DICOM files. So if you want to link all these together, if you want to link the 3 studies together, or link the 3 examinations together, you might actually consider them or label them as basically composite instances. It's a part of more than one. So basically, this would be a part of more than one here. Okay, so it's a part of examination that includes multiple parts. Okay, so basically, it's by far the most composite instance is the DICOM image itself, basically, which is basically usually, as I said before, DICOM images usually, if you have T1, T2 proton density, usually have each one of them as a separate DICOM file. So basically, it's one of the things that you can see that basically they can represent a part of more than one. Okay. It's very important to also have, as I said before, the presentation states. You record the adjustments or the manipulations that happened by the doctor, by the reading doctor to these images, so that the original image is not affected. For example, if I get the image, I magnify it. Okay, if he likes the image magnified, okay, that's fine. You can record that operation and keep the original data. And whenever the doctor needs to see that magnified image again, you get the original data and apply that operation again, so that you can he can see it the way he likes it. Okay, but actually the original data is not affected, because the original data you can actually you can go from the original data to the manipulated data, but not necessarily the other way around. Okay, sometimes when you actually change the resolution of the image, you cannot go back. So basically, it's very important to keep the original data, and basically, have a presentation state, okay, which basically change from a doctor to another, and basically you can apply it or remove it, but you still have the original data, to do whatever you want with. Sometimes you have something called radiotherapy objects, okay. Radiotherapy objects they are kind of DICOM. They are similar to DICOM images produced as output to diagnostic encounters, but they are not images. Basically, they are kind of planning information. Okay, so instead of having an anatomical image, you basically have a certain way of or a certain distribution of the dose that you would like the patient to have for a certain treatment operation, for example. Radiotherapy is, by the way, usually is related to imaging. Basically, sometimes it's usually imaging is very important for radiotherapy because basically the input to the radiotherapy planning is usually images. So you start from like CT volume, for example, and you do the radiotherapy planning, and the outcome of this radiotherapy planning is not in the form of an image, but rather than that, it's basically it's a radiotherapy dose distribution or the planning information. Meaning that where you're going to put the radioactive sources, for example, if you're using basically implantable radioactive, like brachytherapy, for example. If you're using gamma knife, if you're using linear accelerators or things of that sort, you might have different information, basically have different information about how to apply the radiation to the patient. But actually, this information might be actually a radiotherapy object, basically. Okay, so basically this is one of the things that you might actually see as composite instances. Sometimes you have also what's called structured reports. Okay, so basically structured reports means that it's a framework for issuing reports in a reproducible manner. Okay, so it's very similar to having each report being from a template, meaning that instead of having each doctor writes his own report in a different way, you actually have certain templates and the doctor just fills out these templates, okay? There are so many different report generation softwares, by the way, and this is one of the things that you might have, or the doctors actually find very convenient, because basically they optimize their time. You don't have to write a lot. They basically write the most important information, and they can fill out the rest of the report from a template. So basically, this is one of the things that you can use actually composite instances in. So the DICOM file itself used to be named as DICOM data objects, okay? And it usually consists of a number of attributes or components. It has some kind of a preamble, meaning that it's some kind of an identifier for the file data type and components of whatever the data, whatever data are included in that file. And usually you have a block of data, which is commonly known as the DICOM headers. And basic DICOM headers actually has a lot of information about, as you see here, the patient demographics, all the patient information is there. The technical information about the image, basic means that the imaging modality that was used, the specific scanner that was used, the model of that scanner, the update, the software version of that scanner, the particular, if you're using, for example, MRI, the particular sequence that was used to acquire that image, the parameters of that sequence, everything that would give you exactly the complete information about how this examination was done. Okay, the study itself, okay, what if you have T1 weighted, or if you have, for example, CT of the brain, for example, whatever. So basically, you mention exactly what study was done. The acquisition parameters was basically a part of that. The acquisition device, which is also part of the thing that we talk about the technical information. So basically, technical information includes all these things. And there are actually a lot of information that we are basically that we can see actually other than that, okay? One of the things that I'm going to do is I'm going to post one DICOM image, and basically I'm going to send you a very small MATLAB code that would allow you to look at the data from that DICOM image. And basically, you can actually, if you use ImageJ, by the way, ImageJ would allow you to do that as well. Okay, ImageJ, you can open. There are actually one of the sampled images that are available in ImageJ. Basically, they include DICOM images from different modalities, by the way. And whenever you open a DICOM image, you can actually, one of the options is that you can see the DICOM header and you can see all the information that it has. Okay, so this is very important. So all these are basically like data associated with the image. After that, the image data itself comes later, okay, like a block of bytes, okay? And usually the image data might be compressed, might not be, it depends on the format, but actually the usual format that is currently used for DICOM version 3 is JPEG 2000 format, okay? But it depends on the, basically it has certain standardized format that people can read, basically. And usually you allow this kind of format would allow for images with higher than 8 bits per pixel resolution, okay? So basically this is very important actually. This is the image data itself. So the DICOM format or the DICOM file as we see here, it doesn't basically contain the image only. It contains a lot of things, not just the image. It has many pieces of information that would make it much more complete than the regular image file that would have as a JPEG or whatever, okay? The JPEG would have only the image information. Here you have all the information about the study, about the patient, about the, if you want to repeat that study again, if you see something wrong with the study and you want to repeat it again, you can actually have all the complete information about how it was acquired is there, okay? So this is actually very important to know. So the DICOM header itself, each image is generated definitely by the medical equipment, the acquisition modality, basically. Basically, we talked about the terminologies. In DICOM, it's basically the modality here, okay? And basically, you store within basically a chunk of information about the technical aspects of the image, patient, and transfer method at the start, followed by the actual image data, as we said before, basically, in the previous slide. Usually you start with identifying information, basically, go back. This is the preamble that we talked about. You basically, the DICOM tag, basically, which has basically the pieces of information that are included in the header. Basically, you have certain tags, and each one of these tags would correspond to a certain piece of information. Usually you have a certain code, and this code is easy for the machine to learn. Or basically, if you have certain, for example, tag that has 0020 or 0021, the machine can basically know that this 20 is basically corresponds here, as you see here, corresponds to the study. And if you have 21, it's basically the series data, for example, or a series date, which is a little bit different, okay? So basically, this is machine readable, but actually it's nice also to allow the user, a human user, to be able to understand what this stands for, okay? So you usually have like a human readable form of the command itself, okay? Or that particular header, okay? Or the particular tag, okay? So you have a numerical code, you have a human readable code, and at the end, you basically have the data itself for that particular tag, okay? So for example, the study date, you have the year, and you have the month, and you have the day. And usually here you have the length of the data that is expected here. So basically here you have 8 digits. You have here 4 for the year, and 2 for the month, and 2 for the day. So basically this specifies exactly the length that you expect, the number of characters you expect for each one of these. So as you see here, if you go over these kinds of examples here, you have, for example, image type, you have a length of 34, for example, okay? So for example, you have here original, might be original, primary, axial, CT, whatever. Basically, it has an identifier of what image type is included there, okay? So basically, you have also SOP class UID. Basically, you're talking about the unique identifier for the machine itself, for example, okay? So basically, you have different things here. You have, for example, image time. Basically, it's related to when the image was acquired, for example. You have acquisition time. You have a lot of parameters here. So usually, the DICOM tag is composed of 2 blocks of hexadecimal characters. We talk about the tag. This is the tag part. Uh, you have 2 blocks of hexadecimal numbers. Okay. So basically, these are hexadecimal. So basically, you might have numbers of basically A and B and C, basic hexadecimal, not just decimal, okay? And you have this tag, basically, you have these two blocks of hexadecimal characters at the start of each row. So as you see here, each one of these is a row, okay? And basically you have each row group and element numbers, okay? Group means that this first one is a group, and this second one is the element, because sometimes the operation can be grouped together. So basically you have a certain group for image parameters, for example. You have another one for patient data, for example. So basically each one of them would have a different group, and within each group you have different elements, okay? And these reference parts of the standard, usually these are the standardized, by the way, they are not arbitrary. You can actually find these in the standard itself. And it helps the equipment know what information is being presented, okay? So basically, whenever you read these, whenever you read the DICOM file, you read the tag, and based on the tag, you know exactly what information to expect at the end, okay? The length here advises the maximum number of characters that you should have here. The description here is basically, it aids human interpretation, but provides short explanation of the row. Basically, it's the name of the row. Basically, it doesn't have to be lengthy, but it's just an explanation. Whenever you read it, you know exactly what this represents, okay? It's actually useful because it's not always convenient to just present everything in numbers. Sometimes it's good for a human user to examine such information. So basically, you should allow an easier way for the human user to be able to understand it. You have value representation. Basically, it means that basically the type of value system that you'd expect to find, like for example, you have it's like when if you're working with Excel, for example, you're able to change the format of a certain cell. For example, like a date, like a percentage, like a decimal number, and you can specify a certain number of digits, things of that sort. Here you have things of that sort here. So basically, if you have DT, it's date and time. If you have date, basically it's DA, it's like date. If you have time, it's like TM. So basically, it allows you to know exactly what kind of information to have here, okay? So this is important because sometimes you need to verify that this is actually compliant with this, okay? So if you get a date that doesn't make sense, then you can actually verify that it's basically you can realize that it doesn't make sense by looking at the expected format for the representation of the data. Sometimes you have what's called value multiplicity, which indicates how many values are provided. Sometimes you have multiple values for the same one, okay? Basically, sometimes you have, for example, if you have, for example, the first one here, specific character set, sometimes you have more than one, okay? Meaning that you might have certain character sets, multiple character sets that you can use, okay? For each one of them, you have basically, you might have, if it's one, then it's only one value here. If it's two, then you might have more than one value. Same thing for image type. So basically, this would tell you how many values here to expect. And then at the end, you have the actual value itself, okay? There are some unique identifiers. And basically, I think we should finish this and basically call it a day for this lecture. And inshallah, next time we complete this standards part. You have several unique IDs, unique identifiers that are generated within each modality and included within the produced images. For example, information about the generating devices, patients, individual encounter, okay, and files making up study, okay? So for example, if you look at this one here, you have unique ID for the modality itself, okay? And you have a certain instance, for example, if you're communicating with a certain, if you're communicating now with another equipment, maybe you can generate another unique ID so that you know that this communication happened and you have a unique identifier for it, okay? And also, if you have a patient, you have to have a unique identifier for the patient. We don't have here patient information, but actually you have to have a unique identifier for the patient. Okay? So basically, usually you have each one of these images would contain different unique IDs to link it to the remainder of the series and the exam, okay? And overall patient count. For example, you usually have a patient that does a study. The study is composed of different series, and each series has several images. Sometimes you actually have the whole series in a certain DICOM file. Sometimes you have the individual image as a DICOM file. So you need to link each image to the other images in the series, and all the series that you have to, to the study that, where that study with that basically series required, and basically link all the studies to the same patient. So if you have a unique ID for the patient, a unique ID for the study, a unique ID for the series, a unique ID for the image, and you link, basically you have all this information within the DICOM file, then within the image, these will be unique. You use the unique information for these, and you know that this image is a part of this series. And if you have multiple images, they will know exactly that they are a part of the same series if the series ID is unique between them. Okay, so this is very important. So basically, globally unique from the various issuing registries, which, so basically it's not like arbitrary thing that each modality would do. No, it's not like that. If you're working with a certain equipment, basically, it would have a certain unique ID for that equipment and a certain way of generating the unique IDs from that equipment, okay? So this would be actually different from another modality and from another vendor, so that you have uniqueness between the different studies from different vendors. Okay, so this is very important. Okay, so basic unique IDs generated for DICOM services all begin with the leading digits, like 1, 2, 840, 10008, and then you have other numbers here that would provide the unique ID for that particular identity. Okay, so basically it depends on it depends on the how the other numbers are generated. But actually, once you see these numbers, you can identify that this is basically a unique ID for an SOP class. Okay, so basically this would actually make it very easy to distinguish. If you have certain network traffic other than this, you can actually identify it very easily. And basically, this would actually make things a little bit easier in the interface part. Okay, so basically it's very important to realize that we have unique identifiers, and such unique identifiers would allow the images that are generated by a DICOM modality to be basically linked to other images from the same modality, for the same patient, for the same study, and basically make things a little bit easier, or much easier actually for the back system, for example, to group images together. And whenever a part of the study is received, basically can be basically related to the other parts whenever they are received, so that you don't have a problem with basically missing any part of the study. Any questions? Next time, inshallah, we're going to talk about some of the public tags, some examples of public tags, and what's called private tags. Public tags are basic common between all vendors. Private tags might actually be unique for each one of the vendors. It might actually save some information that are intended for each vendor for like research purposes, quality purposes, whatever. Okay, so basically we're going to talk about these. I'm basically going to talk about the part about the display of the images. And basically this is very important. And then we're going to talk about HL7, inshallah. Okay, any questions? Let me first, if you don't have any questions before I stop the recording, and then I'd like to talk to you about the lecture next week. Any questions? Okay, so I'm going to